Hi! Today I'm going to be talking about water. And water is a chemical that's really important in life because it has properties that sustain our living functions and the metabolic reactions in our body. And so to introduce water, we've got water molecules. Water is composed of 2 hydrogen atoms and one oxygen atom. And they're all covalently bonded to each other. And what gives water most of its properties is the polar nature of water. And okay, so polarity arises from the fact that because the water molecule is covalently bonded, right? And so they have 2 electrons that they have 1 electron each that shares the bond that bonds the 2 molecules together, the 2 atoms together. And because oxygen also has 6 electrons in its valence shell, we got because there's 2 here, right? And so there's 4 more out here. These are called lone pairs. These are paired. And so that's what gives the oxygen side a negative charge because we've got lone pairs, right? And electrons are negative charge. And then so that means the hydrogen atom, this side is relatively positive because this side is negative. And this is also what gives the water a bent shape because these electrons here in the hydrogen area, they repel from these lone pairs, and so it gives the water bent angle of around 105 degrees. And so, and also the thing about water molecules is that the oxygen atom and the hydrogen atom have relatively high electronegativity differences, and that means that when like the hydrogen and oxygen are bonded and they share an electron, the oxygen pulls the electron closer to it than the hydrogen does, so the oxygen gets more of the charge of the negative side than the hydrogen does, and therefore the oxygen molecule is polar, which means that one side is negative and one side is positive. And so this polar nature gives it a lot of its properties. So for example, we got its thermal properties, which arises from its ability to form hydrogen bonds with other water molecules. And so water has high specific heat capacity, which means that in order to raise the temperature by 1 gram of water by 1 degree Celsius, you need to have a lot of energy. And it also has a high heat of vaporization, which is the fact that it needs a lot of energy for it to change into gas. And that's really good for us because, especially like when we sweat, and water evaporates from our bodies, the water needs to absorb a lot of heat in order to evaporate, right? And so it takes a lot of heat away from our body, which helps us cool down. And also, water has a high heat of fusion, which means that it requires a lot of energy loss for it to turn from liquid to solid, and that kind of helps us, the water inside our bodies, not to freeze. And so, because these properties arise because of the hydrogen bonds between the molecules. And so this is hydrogen, right? And this is, as I said just now, is positively charged, and this part is negative. And so the interaction between these 2 molecules are called hydrogen bonds. And hydrogen bonds, for those of you who don't chem, don't take chem. Hydrogen bonds are one of the strongest intermolecular forces they have, and so in order to break these bonds and turn them into gas, or reform them to turn them into solids, it takes a lot of energy. So, and that's why water has such a high heat of vaporization and high specific heat capacity, because they need a lot of energy to break these hydrogen bonds to make it evaporate or melt. And also, water has a lot of properties that's related to cohesion because of hydrogen bonding again. And so cohesion means that water molecules, they stick to each other. They adhere to each other because they have polar attractions and hydrogen bonding with each other, so they can stay together. And also it also has adhesion, which is the fact that they attract to other polar molecules or charged molecules. And one of the examples that they have in the living world is the xylem of plants. Because the xylem, what it does is, for SL students, if you guys don't know what xylem does, is it like pulls the water up from the roots. It's a structure in the stem, and then it like pulls up the water, like against gravity, and then and so it distributes to the plant the sections that are like on top, and then so in order to do that, the water has to be able to like stick to the xylem walls, which is adhesion, right? And then water also has to be able to stick to each other, so then it like kind of climbs itself up, and so that's one example of what water is useful for, especially in plants. And lastly, water is a good solvent because it is able to dissolve a lot of organic and inorganic molecules that have electronegative atoms. And so, for instance, we've got salt, which everybody knows is sodium chloride. And sodium chloride is a ionic structure, so technically it's supposed to be like a crystalline structure, but I've got two molecules, and so we're going to stick with that. And sodium is positively charged, and chlorine is negatively charged, right? And so what happens is when this touches water, the polarity of the water is so strong that this can actually separate, and the positive one can stick to the negative side, and then the negative side sticks to the positive side, which then causes the atoms to dissociate, right? And so this dissolves. This is what dissolving means. Yeah, and so this is useful because a lot of the transport that's happening in our body, it is basically water just transporting dissolved materials into like different parts of the body, because that makes it faster and more efficient for the body to process these after they get it. Yeah. And water actually has a lot more properties. For example, we've got like the fact that water is transparent. It helps creatures living underwater, especially the ones that need photosynthesis. It helps them get the sun that they need. And also the fact that the water expands when it's frozen, it makes the ice less dense, and therefore oceans don't freeze. And a lot of the organisms that live underwater, they can survive even in like freezing temperatures, because like only the top layer freezes. Okay, that's it. Thank you.